on example 2, you've described it to words to your partner. Now, the table of values, that's where, right, we make a T-chart. We have our figure number here. What letter do you want to use for figure number? F, okay. And circles over here, and you want to use C? Okay. Okay, I've got an extra. So in figure 1, how many circles do we have? We have 1. In figure 2, how many circles do we have? We have 3. In figure 3, there are 5 circles. In figure 4, there are 7 circles. Do you notice that you are going up by how much each time? And this is always going to happen in a linear relation. That as you go up by 1 with the figure, the number of circles will go up by the same amount. In this case, we're going up by 2. And that going up by 2 gives you a hint for part C to write the equation. Okay? When writing the equation, you are always trying to figure out how many circles or however many things are in your second part. How many circles are there? Well, because we're going up by 2's, your formula will always have a 2 times the figure. Now, what would make it work? Right? Minus 1. Because if you times 3 by 2, you get 6. Subtracting 1 would give you 5. Check it out with 4. Times 4 by 2, you get 8. Subtract 1, 7. Sure enough, it works. And once we have the formula, we can solve all sorts of equations. Driving. Probably. All right, I am back. So how many circles would figure 71 have? So in part D, you know that F is equal to 71. We go to our equation, put in brackets because we can substitute in. So remember, when you're substituting a value in, you put it in brackets. And now what does, oh, I forgot the minus 1 here, right? Now we can just do our order of operations. 2 times 71, 142 minus 1, and so you get the number of circles will be 141 in figure number 71. What figure would have 83 circles? So part E, what figure would have 83 circles? So now we can plug in 83 for C. Can you see in this question, I wouldn't have to put brackets around it, because the brackets would just, they're there to hold a number to make sure that if there's multiplying or something, you're not missing that. But in this situation, the 83 is all by itself on the right-hand side of the equation. So we wouldn't need brackets. We still have 2f minus 1. So basically, this is asking, I have a number. It gets multiplied by 2, and I subtract 1, and it's equal to 83. What's that number? And we've learned with equations, oh, does anybody remember the undoing of BEDMAS? Yeah. SAMDEB. Right? We're going to add the 1. Exactly. That'll give us 84 on this side, because those are like terms, and 2f on this side. Opposite of multiplying by 2 is dividing by 2. And so we get that it would be figure number 42. How would you verify? Because this question says verify. Right? You'd have to plug in 42, see if it works. 2 times 42 minus 1 is 84 minus 1 is 83. Check mark. It works. Now, one of the places we're going to go in this unit with this idea, these are called linear relations. And the word linear, what does that make you think of? Lines. Okay? And the reason they're called linear relations is because if you take your chart, so let's look at the chart that we have. I'm going to just copy it. Whoa. Wait for it. I'm going to copy it like this. There we go. I'm going to move it down somewhere down here. There we go. We've got a chart there. Now, each thing in our chart, we're going to find out that can represent a point. So 1, 1 could be a point 1, comma 1. 2, 3 can be a point 2, comma 3. 3, 5 can be a point 3, comma 5. And 4, 7 can be the point 4, comma 7. And if I take each of those points and put it on a graph, you've learned that this is which axis, x or y? Ooh, have you learned that?
Yeah, but I don't remember.
Oh, that's your x, yes. And up and down is y, right? And then you go this way, 1, 2, 3, 4, 5, 6. Do you remember doing this? Okay. So if you go to the right, do you remember that this is going positive this way? 1, 2, 3, 4, 5, 6. If you go to the left, it would be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. And if you go up, it would be positive 1, 2, 3, 4, 5, 6, 7. And if you go down, negative 1, negative 2, negative 3, negative 4, 5, negative 6, negative 7. And so if you want to show the point 1, comma 1, your x is 1 and your y is 1, that's going to be perfectly right here, 1, comma 1. And that's not too hard. Where you get into trouble is when you have the point 2, comma 3. Which 2 do I use? This 2 or this 2? Right? The first is always your x. The second is always your y. So if I had 2, comma 3, I'd go to 2 and to 3 and I draw a dot. And then I have 3, comma 5, I go to 3 and then 5 and I draw a dot. And then 4 and then 7 and I draw a dot. And what shape do those dots make? A line. That was a lot of explaining. For the reason they're called linear relations is because they are lines. And one of the things that you study a lot in math is graphs and their equations. In fact, grade 10 math next year, for many of you that are deciding to take pre-calculus and applied, in grade 10 math, you are going to study what the equation of this line is. I'm going to tell you, and I want you to see if you can figure this out. How did I get the equation of this line to be y equals 2x minus 1? And how is it related to something we already did? Any ideas? The equation of this line happens to be y equals 2x minus 1. How could I use the stuff that we did with our circles and our figures to figure that out? Any ideas? Judah, you got an idea? No? One? No? Okay. So Look at what we did in this question already. I see people spinning their pencils, right? If you want to spin your pencils, you go back in time, right? I can make recommendations. Hey, want to spin pencils? They did that lots in middle school. Let's go back to grade 7. If you want to continue in math in high school, you got to focus. And so here is the equation of this line. Y equals 2x minus 1. It's related to something we already did in this question. Look for a pattern. Look for where there might be something similar. And see if you can figure out how I got the formula for the line based on what we figured out with our figures and our circles. For this particular line, through these points that were our figures and our circle points, is 2x minus 1. What have we done already in our question? We started with our table of values after describing in words. What did we do next in this question? After getting the table of values, we got the equation. What equation did we get? We got circles equals, it's the same equation, just different letters. Because what did I say? This was your x. So this is your y. It's the same equation. So when we graph things with y and x, but that's just changing the letters. It can still be the same idea that you had before. And so a lot of grade 10 math is about graphing lines. Grade 9 math, we're just finding the formulas. We plot the dots, but we don't have to graph the line yet, as intense as you will in grade 10. But if you make the connection now, that can make your grade 10 math easier. Question number 3. Again, draw the pattern for the first 4 rows. Try that on your own.
I drew it. It just takes a long time.
It does take a little bit of time.
So it's just lots of circles.
Just lots of little circles, I know, because the first row has, well, or lines or X's or squares or whatever you want.
Oh, I see it now.
So it tells you it's in a rainbow shape. So the inner row has 7. Then the next row has 12. Are my colors going in the right order for a rainbow? I was trying to remember the colors of the rainbow. 22. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Roy. I got blue at the bottom. Should be, it's red at the top. Roy. G. V. Oh, I forgot the violet. The violet would be there. I just drew the middle part because we don't have the red either. That looks so pretty. There's a rainbow. You know, it's also pretty sunshine. It's sunshiny today, and then it's supposed to rain all weekend. And there's still snow. But the good thing is it's not May yet. Yet. So we've drawn our first 4 rows. Can we make a table of values? Are you okay with row for the first thing as an R? And then chairs? C. Row 1 had 7 chairs. Row 2 had 12 chairs. Row 3, this is a great color to use, had 17 chairs. And row 4 had 22 chairs. Is there a pattern here? +5. Does that help us find the formula? Probably. Our chairs, so in part C to find the equation, our chairs are going to equal 5 times our row plus 2 makes it work. Beautiful. Use our equation to verify there are 22 chairs in row 4, so we would replace the R with 4. Whoa, got excited there. Wow. (20 + 2), does it work out? Yes, it does. Verified. So when it asks you to verify, they want you to plug in the numbers to check to see that it works. How many chairs would be in the 7th row? So we're going to replace the R with 7. And you get 37. Now, some of the math that you get to do in grade 11. In grade 11, they'll ask you questions like, if the theater had 7 rows, how many people can go to a concert? What would you have to add? All of those up. 5 + 12 + 17 + 22 plus. But it continues the pattern. They say there are 7 rows. How many people can go to the concert? Then you just have to add up all those answers. But there are techniques that you can do to add it up quicker. Because if someone said, oh, but I went to another place where they had 50 rows, how many people could go? A very big number. Okay, so notice at the bottom of the page, you have textbook questions that you can work on, page 217. You also have your intro activity that you need to finish up. Once that is done, you can hand it in. Here's the intro activity. You might have missed this as well. So we have 25 minutes left. We're going to work on those things.